All right, guys, new lesson, new beginning. So now we're going to talk about polynomials. Again, this is kind of like a review on just using more than one x. That's essentially a good way to kind of think about a polynomial is using more than one x. Rational expressions is when you think rational, think of this word ratio. Ratio is like, let's say the odds are 3-1, right? So, in other words, 1/3. That's when you think of rational, just think of fractions. That's all rational things are. So, when we're talking about rational expressions, that's what we're talking about here. So, our objective in this lesson is to identify the parts of a polynomial and rational expressions. So we're going to talk about those parts and interpret what each part represents. So we're going to look at these functions and try to understand what every little part of it means. Don't just think of these as numbers. Think of every little thing means something. So before you answer the question about factoring expressions, uh, so here's a review on factoring expressions. Any of you who have ever come into the Nook for help or have taken one of my classes knows that the way I like factoring is this thing called the box method. The box method, also known as the area method, is this idea of area equals length times width. When you're factoring, what it's really saying is something times something else. These are called factors. So for example, if I have the expression 2 times 3 is equal to 6, 2 and 3 are factors of 6. 6 is our product, and 2 and 3 are our factors. That's what factors are. So the reason why the area method works is because length times width. So if I put this idea of x squared, 14, and this 9x, basically saying that whatever this is plus whatever this is equals this 9x, that's going to let us, that's going to help us out. So what we're going to do here is we're kind of putting these pieces together. So what times what gives us this area in this box right here? So in order to get that little box, we're doing x times x. Now we want this box. How do we get that? I'm going to say 2 times 7. Now, in order to verify this, we're going to say, what is 2 times x? Okay, so x times 2 is 2x. 7 times x is 7x. If we add these two up, we get that 9x. So in other words, my length is x plus 2, and my width is x plus 7. So this is what's known as the area method. I call it the box method. So that's how I'm able to figure this out. They're going to go into all this. I like the box method because guess what? If I got these wrong, like let's say I was being lazy and I'm like, I don't want to do 7 times 2. That seems hard. I'm going to do 14 times 1. That gets me 14, but then I'm going to get x and 14x. It's like, oh, I shouldn't have been lazy because these two don't equal 9. So then I have to go back and I just erase this and I try again. So that's all we're doing when we use the box method for quadratics. So when I do this, it's ironic that they talk about like how to factor this. If we want to factor out, we can just think of it as backwards distributed property. If we did this, we're factoring out an x. What can we divide both of these by? What's a common factor? They always use the term greatest common factor. I want to kind of get rid of that. What it means by common factor is what can we factor it by? Well, think of factoring. If we're using factor as a verb, think of it as dividing by. What can we divide both of these by? The word common is this idea of the same. What is something that we can divide both of these by? Hey, it's Nelson. Oh, Nelson disappeared. Oh, it's okay. You know there's a mute button, right? I know you do because you always mute yourself. That's okay. um, so this idea of common factor is asking what can we divide both of them by? Greatest just means what's the biggest thing we can divide both of them by. So that's the idea of greatest common factor, is what is something that divides into both of them. So that's what GCF means. I don't think anyone ever explains what a factor is. A factor is something that goes into it, something we can divide it by. So if we factor out, it's like, well, how can we do this? Well, 3x is just 3 times x. So both of them are technically 3x. So what does this factor represent? Okay, so factor. This factor, x plus 3, right here, is this idea of there's 2 of them, so it's a binomial, and it's going to represent either the length or the width. All right, so if we're thinking there, where x represents the width, so that means this has to represent the length. X represents the width. If we divide it out by our GCF, they're just saying our x. We don't know what the width is, so we're just going to call it x. Well, what do we know about this? Well, it's whatever the width is plus 3. So that's just our length. I know I got really into it, but they got into like factoring quadratic expressions, so I figured I'd go into that. So that's all we're doing here, the area method. Again, just watch the introduction on your own. Interpreting polynomial expressions. All right. So when we're doing this, these are examples of polynomials. Polynomials are just any expression with x's. Sometimes they have more than one x. Sometimes they only have one x with an exponent. That's what polynomials are. It's just this idea of an unknown. Sometimes it has an exponent. Sometimes it doesn't. The first term, a term. So if we're talking about terms, are always separated by a plus or minus. So for example, if we're talking about this term, the negative comes with it. This is a positive one, so this is a positive one term. So these are words that we kind of need to get used to because I am going to be using it a lot. Coefficient is this number in front of it. And that one also does carry the thing. So coefficient is a number in front of the variable. A little bit of review there. So, and a degree is the power. What power? Constant means no variable. Leading term, well, that one should be obvious. It's whatever's in the front. The whole term that's in the front. And I want to say that there is vocab on the test. So make sure you're understanding the vocab here. Can you represent expressions? So now we're going to use words. So those of you that struggle with word problems, I'm one of them. We're going to talk about how to say terms in words. And one thing that we'll realize is that they're always backwards. I don't know why. They're always backwards. So you kind of always start off working your way out. So, for example, here, the difference of x and 4. So, when we say that, we're saying the difference. So, we're saying subtraction x and 4. Cubed. So, then we cube it times 6. And then we multiply it by 6. So, it would look like this. And we'll see that most of these kind of look the same, right? So in this case, if we're looking at the difference of this, we're looking at this one over here. Now that seems obvious because I broke it down slowly, but watch this. 4 less than the third power of the product of this. So let's kind of start going out. 4 less than. So let me kind of go backwards. 4 less than, which means we're subtracting, less than third power something to the third power of the product of 6 and x. So we're multiplying something, and what's that something? 6 times x. So if we look here, this would be this. So if you guys are a little confused at the wording, they're doing this on purpose. They're trying to show you the subtleties of doing it. So you guys can always review this back when I post this video on YouTube. So let's kind of get through this. So this says the product. So the product. So we're starting off with multiplication. The product of x cubed and 6 minus 4. Well, we never like having the variable in the front, so I'm just going to switch this up and call it 6x cubed minus 4. So then if we look here, this one is this. So it might seem easy because I'm doing it, but really try to read these and understand what's happening. So next one, we're going to do 4 less than. So 4 less than 6x, and the cubed is actually referring to everything cubed. So here we're doing this 6x, and then we're cubing everything. So by putting the cubed at the end, it's saying everything we just said, cube it. I know it's the last one, but I wanted to kind of go over it. Is all of this making sense, guys? If you're struggling with it, again, let me know. It is one of those things that, like, the words kind of are a challenge. That would have been embarrassing if I went through all that and I got that wrong. But here, they kind of do an explanation, but they do it with words. I'm like, great. So if you don't understand the words, you can understand it by reading more words. That's the whole reason. Yes, math equals riddle. Yes, math is a riddle. The question is, can you solve it? All right, so oops, let me delete my writing. Interpreting polynomial expressions. So we're gonna try to read this and try to understand what they mean. So now it's saying, oops. So the area of the tiled floor. So I like drawing pictures. I'm a very picture-centric guy. I'm terrible at drawing pictures, but I like pictures. It helps me understand it. So here's our area. Our area is this rectangle. And we have this 4x squared plus 24x plus 27. Okay, so that's all this. Where x represents the length of a single tile, okay, the length of the floor is 9 more than twice the tile. So basically, we have this tile here, and the length of the floor is 9 more than twice, so 2 times something, then twice the length of x. So x plus 9. Write an expression for the width. So we don't know what the width is. That was my bad. We just know that we have this area. And to do this, I'm going to make the box method. So I'm going to be like, okay, so this is 4x squared. And this other thing is 27, our last term. Let me kind of use color coding. I like color coding. So I'm going to use that. This is going to be our last term, and this is going to kind of be our reminder. So when we're doing this, we're doing this 4x squared. We're putting this 27 here, and our little reminder, what both of these add up into, is going to be 24x. So we know that the length of the floor is 9 more than twice the tile length. So in other words, this is our x plus 9. Well, how are we going to get this 4x squared? Oh, I'm going to multiply that by this 2x. That gets us 4x squared. Well, what goes here? Well, 2x times 9, that's 18x. Well, 9 times what gives us 27? 3? Oh, then what goes here? 3 times 2x, that's 6x. This is why I like using the box method for everything. So if we add these two up, guess what? They equal this 24. So that means our answer to this question is x plus x, 2x and a positive 3. 2x and a positive 3. Are you guys understanding how to use the box method? Like how I turned this into this little box right here? Cool. All right, and then they kind of split it. They use, I'm sorry guys, if you guys get a factor by grouping one, I honestly think it's a terrible way to teach this. We'll learn it together as we go through the unit. I'm not the biggest fan of it, to be honest. I feel like you already have to know what it factors into. So if you guys are having trouble understanding Edmentum's explanations, whoever wrote it was a big fan of factoring by grouping, and I can try to like help you out with it. But I honestly think it's one of the hardest ways to factor. I use the box method. I just think it's easier. But if you guys want to learn how to do the factor by grouping, I can teach you guys how to do that. All right. So volume of a cone. So just a refresher on some geometry. When we're talking about volume, we're basically talking about the area of the base times the height. So some of you guys know this as volume equals length times width times height. So if you guys thought that geometry was over, I'm sorry to say that they bring it back. Edmentum brings it back a little bit here. So the volume of a cylinder is this. So the idea of this is we're going to use this formula right here. It's a circle, so we're doing pi r squared for the area of the base, and we're going to multiply it by the height. So that's how come we have this length times width equals height, but instead we're using pi r squared instead of length times width. So what's happening here is this volume is this idea of a different type of area. We have a pi r squared times our height. All right. So in this case, we have this pi r cubed, and then that's going to be plus 7 pi r squared. Well, if we know our height, if we know that this has to be pi r squared, this is a different type of box method, by the way. This isn't a trinomial, it's a binomial. So this box method, even if you've taken me for algebra or asked me for help in algebra, you probably haven't seen this little method of doing it. We're doing like a smaller box. So how do I get this? How do I get this part right here? Well, I know there's a pi, so I don't have to multiply by pi, and there's an extra r. R squared times r equals that, so I'm going to put an r right here. Cool. This one, we're missing a 7, so we're going to do plus 7. So in other words, if this is our base, our height is the radius plus 7. So here we're going to say the height of the cylinder is 7 greater than the radius. I don't like how they use the word greater than, it makes me think of this. So if you guys are confused about that, I'm right there with you. I don't like that they use the word greater than. Especially because later on we will learn about inequalities. In this case, when they mean greater than, they're saying plus 7. And I'm so sorry that they're going to make it confusing later on when they talk about the actual inequalities. Wait, what? How did I do this wrong? That can't be wrong. 7 units greater than the radius. The height of the cylinder is... Oh, 7 units. My bad, guys. Not 7 times greater. 7 times greater is 7 times r. That was me not reading words. So I apologize for that. We're only human, right? I'm not perfect. I didn't read it. Sorry. All right. So now, oof, there are so many words. Let's get into it though. I'll kind of like break it down little by little. This is basically just using a real world example. If you're like me, um I'm really bad at reading, so I kind of look at all the numbers and I highlight. So I invite you guys to do the same thing. Use your little highlight tool. So what's going on here? So I'm going to use my yellow highlighter, and I'm like, high school baseball, I don't care about any of that. I know that's a terrible way to kind of teach. If you guys like imagining the picture, go for it. Read this, talking about volunteers and football teams. I like getting just straight to the numbers and trying to figure out what those numbers mean. When they charge $2 a hot dog, so what's happening here? Oh, they're charging $2 a hot dog. So I'm going to highlight that. So you just highlight it with your cursor and then hit the little highlighter. The average sale, so average sale of hot dogs is 70. That's a different fact. Every time we increase the price, so when we increase the price, that's a terrible color. The number of hot dogs decreases by 8. So then they came up with this formula for revenue. So here's this really complicated formula right here that they came up with. I wish they had more colors. They don't have more colors. So I'm going to remove that highlight. I'm going to use my own little highlighter. So we have this really weird formula. But we want to figure out where X and the number of hot dogs increases the price. So let's think about it this way. What is average? Average is when we add up all the hot dogs and divide it, right? So we're taking the number of hot dogs and that's going to be our average, right? So in other words, give me a second. A better way of doing this is we're taking our money and dividing it by the price of a hot dog. Hot dog. This is why I'm not an English teacher. And that's going to give us our average, right? But this is saying every time, every time. So in other words, if we take the price of our hot dog and we take away X, our the number of hot dogs we sell decreases by 8. So let's kind of break this down. They gave us this formula. What is the constant of this polynomial? This 140. What is this? Well, this 140 is how many hot dogs we're selling normally. So how many hot dogs we sell normally. And I know I kind of went on a tangent there about explaining all this other stuff. But the main idea here that we're doing is trying to understand all this information before we start asking the questions. So before we even do anything, before we mess around with all of this stuff, what does this mean? So before we're messing around with price changes, all we're talking about is how many hot dogs we're selling. So that's how many hot dogs we sell. That's all it means. So this next question, how can we factor this out? Okay, so first thing, this is a has really big numbers. So first thing we want to do is factor out our GCF. Well, I know we can divide by 2, but can we divide by more? I'm going to try dividing by -8. I'm going to try dividing by -8. I know this can be divided by -8 nicely. We want to look what divides into them nicely. And we're just trying stuff out. Sometimes we have this memorized, sometimes we don't. I honestly don't know if 8 goes into 54. It doesn't. So back to the drawing board. What else can I take out? Let me try 4. I already know 2, but I want to try 4. Because I know 4 goes into 8. I just don't know if 4 goes into the other stuff. So 54 divided by 4. Nope. Looks like I have to factor out a 2. So I'm going to take out a 2. So what I'm going to do here is I'm going to take out this 2. And so I'm factoring out this 2. I'm dividing everything by 2. And I'm going to get this 4x squared. It's positive now. Minus 26x, because it turned into a negative, minus 70. So now what I'm going to do here, are they factoring by grouping? They're factoring by grouping. Why are they doing this? I'm going to keep going, and I'll show you how this kind of goes into play later. I really wish they didn't factor by grouping, because it ruins a lot of learning opportunities for you guys because they're so focused on factoring by grouping. They want us to make this. I could have taught you guys about GCF and all this stuff, but they basically want me to make it so much harder, and I'm not really into that. So I'm going to go into this box method. So I'm going to do this thing right here. It looks like they want me to do negatives. I can tell you right now, this doesn't work because 8x times x, this doesn't work because that's going to give us a positive thing. So we know that one's wrong. And I wish I could teach you guys more than just elimination practices. This is wrong because x times 2x won't get me that. So right off the back, I know that one's wrong. Are you guys understanding what I'm doing? I know I'm like busy ranting about how Admentum doesn't really teach, but is this making sense so far at least? Cool. So another thing I know won't work is this one. This one doesn't work because -70 times 2. So if I put -70, oops, I'm supposed to put -70 over here. Basically what I'm doing is I'm matching this with this. Give me a second. And then I'm matching this and this. So I should put, so this is a negative and this is a +2. If I do that, I would get negative that, which this is not negative. So because they're not doing the GCF, this just becomes an elimination problem. This cannot work. So by process of elimination, my answer has to be D. So that, again, they're doing factoring by grouping. It's annoying because how did I know to use a -16 and a +7? There's no way to have known that. The thing that they're kind of going off of is like, oh, well, you can factor out an 8 from 16. Okay, so why didn't I use why didn't I use this? Negative this, and what would the other thing be if I want to get this right here? Positive, I have to add it by 8, 62. Why didn't I use this? And the answer is this person already knew what this answer was. And that's not a good way to learn. Um, so that's why I like using the box method. So if you guys don't understand this, that's what they're essentially doing. They're splitting this number into two different numbers here, and they're doing that. It's confusing, and I don't think it helps. If you guys are fine with this, great. Maybe one day you can teach me how to understand how to do this efficiently. I know how to do it. I just don't know how to do it efficiently. I feel the box method is way more efficient. So if you guys get stuck with a factor by grouping question, let me know when you submit your mastery test and we'll go over that question. All right. Because unfortunately, they do have factor by grouping, but it's really hard to teach why we factor it into this. I can never teach why we factor into it. I know how it works and how that gets us the answer, but it's really hard. Is that fair, guys? Yes, no, maybe. I'm gonna I'm gonna be teaching with a lot of the box method, just so you know. Why is it useful to factor polynomials in this scenario? Well, the reason why this is useful is we know what we're multiplying. Is we know what we are multiplying. It puts it I'm just gonna type this out because writing this out is taking a while. Um, it puts it in terms we can understand. In this case, the idea of price per hot dog times number of hot dogs. That's what we're doing here. So, what does all of this represent? What does this factor form represent? Well, this factor form represents that every time we increase it by $2, so the price of the hot dog plus $2, what's happening here? Uh, well, this is happening to how many hot dogs we're selling. That's what's going on here. The price that we originally had, it's going to start decreasing by this. So, what do these factors represent? So, as we look here, it's saying here, this factor represents the final price of the hot dog. It's the price of the hot dog. So x plus 2 represents the price of the hot dog. And I just realized I could have just submitted this and given you this. It interprets in context of the scenario. In this case, it's talking about price increase, blah, blah, blah. I like my explanation better, but this is also kind of good. Um, so in this case, it's saying that the x plus 2 is the price of the hot dog. Dog. And this right here represents the average number of hot dogs we sell. So again, this negative x plus, what was it? What was the answer? Plus 70 is the number of hot dogs sold. So it says average here. If you guys don't mention the word average, I'm not going to fault you for it. I'm going to assume that every day is like a perfect sale or whatever. So you don't have to use the word average. That's what we're doing here. So this is how we interpret a polynomial. is understanding this relationship of multiplication. Let's see how we're doing on the number of slides. Ooh, we're like halfway through it. And I'm sorry, guys. I know I like went on about using the chat if you guys don't understand something. And again, feel free to do that. I'm gonna try to like blast through this next couple things because I'm already having to make another video for geometry, and I don't want you guys stuck with that as well. Why did it do this? Okay, we already did this. And then this was just going on to the next one. So here we're going to learn about dividing. So dividing, the reason why we kind of learned about factoring is in order to divide, we have to factor. So factoring is easier because if we factor this, it makes it easier for us to do elimination. For example, if we have this 2x squared, we can cancel out this x with one of these x's because if we factor out this 2x squared, it would factor out into 2x times x. And this would factor into 5 times x. And since we're multiplying, since multiplication and division are basically the same thing, they're just opposites, you could just cancel this out. What's x divided by x? 1. So it makes a giant 1. They cancel out. And we're going to do that with factoring. So let's check this out. So this is just this idea of we're taking an expression and dividing it by another expression. This px divided by q. We're just dividing those expressions. So, oops. If I'm doing this, how can I write this down? Oh, so you guys can do this on your own. I'll put the answers up here for you guys to review it and the reasoning behind it. But how do we express this? Well, this is the cube. We're cubing everything of the difference of 4 times x, and 9. This and means we're going to do the difference of it. Why is this wrong? The difference of 3 times y, first of all, that's a plus, not a difference. Automatically wrong. The quantity squared means that everything in this parentheses, we're going to square it. 4 times that. Why is this wrong? The quotient of the difference of this. So the quotient of the difference of 2 times x and this. So right here, this is wrong because it's saying we're doing the quotient of the difference of 2 times x and this. So we're doing 2x and 5. So we're doing the difference of 2x and 5. And we're doing quotient. So we're going to divide this. This and means the next stuff is divided. And 7 times x and 7. Notice how they never mentioned the cube. That's why that one's wrong. Why is this wrong? The sum, that's a negative. Right off the back, it's wrong. So sorry, I know I'm blasting through this. I just want to make sure I get through these next slides. Is this making sense? If you guys have any questions, again, feel free to do it in the chat and I can review it while I'm like super blasting through this really fast. I'm sorry I'm going fast. 2.5 minus 31. So this is just an expression. In this case, the P, so 31 represents the cost of supply. So right off the back, we have to subtract that price. And then she sells a pastry. So this is how many she is selling it for. And then she's dividing it by how many pastries she sold. So this is going to tell us our average profit. Our profit is pastries we sell minus the cost of the pastries divided by that. All right, so moving along. So what does this numerator represent? So this numerator, this top part right here, and the way I remember it is numerator starts with n is like north is on the top. Denominator starts with a D, that means down. Probably a silly way to remember it, but it stuck with me for all these years. So what does the numerator represent? Okay, so that's how much we have to pay for the truck right off the back. And then this represents for every mile. So this represents our cost, our total cost of the thing. And then dividing it by the number of miles would be our cost per mile. We're dividing it by the number of miles, so it's cost per mile. But we're just talking about the numerator. So the numerator represents not the average cost per mile, it represents the total cost of renting the truck. I don't like that they use the word 3 days. It's trying to trick you by giving you another number. All right. And rational expression. So we're going to have this stuff where we add it, and then we have a constant. So here's an average, another average, and we're subtracting. So these are different forms. Instead of just having one thing, sometimes we're going to have a sum. All right, going through this. Again, I know I kind of gave away the answer. I guess I'll just leave it there. But let's kind of talk this. What does this constant represent? The population of Arctic foxes. So this is this represents the number of foxes, where y represents the number of years since then. So we're talking about years. Y is how many years since then. So this number right here, this I can't highlight it because it's a picture. This number right here, what this represents is how many foxes we had in that year. We're always going to get more fox. Well, in this equation, this shows that we keep getting more foxes. So every year it's going to increase. Increase from what? It increases from here. What was here? Here was the foxes in the year 2010. All right. So moving on. Let me delete these. So now we're going to talk about fractions. So this idea of fractions is we can always break down a fraction into its two parts. So if we're adding these two together, that's the same thing as separating them. So let's say we wanted to separate this into two different terms. If we wanted to separate it, both of them are going to be divided by p, but our numerators are basically these two split up. That's why they kind of do this little chopstick thing. We're splitting it up, but they're both being divided by that. Once we do that, it's so much easier to just be like, cool, these p's cancel out. So now we have this constant minus this. So what does this number represent? Well, we'll talk about that when we get into our next thing right here. All right. Why does this always do it answered for teachers? So we're charging this much per month, right? And then in addition, we have to pay for a premium channel for each channel we buy. So if we split this up, every channel we're buying is this. And then, or that's just the cost. And then this over here, this ends up being our cost per channel. This whole question, this whole expression is cost, I should say average cost per channel. This is our average cost per channel. So the more channels we get, technically the less that $40 is costing us per channel. So the more channels we get, we feel less of an impact of that $40. That $40 feels less. So what does this mean? This means that it's the cost of it going down based off the number of channels. So the quotient of the quotient of the cost of X channels without the part. That's not it. That would be this. So if we didn't have to buy that basic cable package. So we know that's wrong. The quotient represents the number of premium channels added. That's not it. That's the X. They already mentioned that. The quotient represents the total cost of that without the channels. Nope, that would be the 40 in itself. So this has to be our answer. The quotient represents the cost of the basic package per channel. So that's why I mean like the average cost kind of goes down the more channels we get. So the more channels we get, the less of an impact that $40 has. All right. And read the following scenario. So Jessica's organizing this, blah, 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 blah. What does the numerator represent here? So the number of people going on the tour. The average profit per person is this, makes this. Let's read the scenario. This activity. What does the numerator represent? Well, I don't know what this 35 represents. So we kind of have to figure that part out. Where X is the number of people on the tour, is the profit she's getting. Organizing the guided tour of the rainforest. The average profit per person she gets given is this. So I'm assuming that this 35 is going to be something that she's already getting paid. I feel like we're missing something here. Usually they build up on stuff, but I don't know what's going on here. They're missing some information somewhere. Okay. Well, what does this represent? This represents the total amount of money Jessica is getting from the tour. We're dividing it by the number of people on the tour because it's going to show our profit, our average profit. So this represents, I guess, a better word would be profit because we're talking about profit. Profit Jessica is getting, or I keep finding better ways to describe it. Total profit. It's our total profit. You could leave it like that, or if you want to be more grammatically correct, total profit Jessica gets from the tour. Assuming we're going to figure out what that plus 35 means later, what does the denominator represent? So the down number, the number on the bottom. They already told us number of people that took the tour. There is an appointment at 11. Yeah, it's okay to leave, guys, because I have an appointment as well. So go ahead. If you guys already answered the question, go for it. Um, just answer the question. I'll put the video up soon. All right. And this one, rewrite the expression as two sums. So we're going to divide this out. So there's 35x. So what they're doing here, they're splitting it up like those chopsticks. And they are eliminating it, and we get this. What does this represent? So this represents, I don't know, because I don't know what that 35 represents. So honestly, if you guys wrote down something like, I don't know what the 35 represents, they never mention it. 35 represents. So, but I assume it's money she gets paid regardless of people. So she probably gets paid $35 just for doing the tour. But if she gets more people, she gets more money. So the 35 represents how much money she makes regardless of tour. So the more people that come, the less that initial $35. At first, it's great. It's like I get $35 just for standing here. Other than that, it's like, oh, the more people come, the less of an impact that is. And the more of an impact I'm getting per person. They're paying $18. So again, here, I would probably give this a 3. And it's not even for me. It's a 3 based off what they said. I 3 for me because I had no idea what this 35 was. They never mentioned it. All right. And then again, guys, watch your summary video so you can get a better understanding of it. Hopefully this helped. I knew I kind of rushed through this, but let me stop